Hey guys, so I'm going to do a video on GCF and DOTS. These are two types of factorings that you learned in lesson 6. So the first type of factoring is GCF that you learned. GCF stands for greatest common factor. So our first example here, we're going to want to first look at the numbers and think what is the GCF between them. Well, I have 7 and I have 35. The GCF that can come out of 7 and 35 is simply 7. So I'm going to pull that out. Then I'm going to look at my letters. I have an A here and an A squared here. Because there's only one A here and two here, I can only pull out a single A. So I'm going to have 7A on the outside. Now for the B values, I have one B here and one B here. So therefore I can pull out a single B. So your GCF is 7AB. And the way that you can kind of help yourself before you make a mistake is write that 7AB underneath each expression, because factoring is basically dividing. So I'm just dividing out that GCF out of both things. So that cancels here, 7 and 7, and A and B, and they all cancel out to become 1. So that's 1 minus 7 and 35 make 5, so I have 5. There's one A down here but 2 up here, so I'm only going to be left with 1 on the top, and the B's will cancel. So I'm left with this. So my final answer is this. Now again, if you wanted to check yourself, you can just redistribute this in. If I do that, I get 7AB minus 7 times 5 is 35, and A times A is A squared, and B. Okay, so the next one is the same deal. I'm going to look for a GCF, and when I look at all three terms, I see that I can pull out a 5. Okay. I also see that I have x values. Now I'm going to want to pull out the greatest amount of x's that I can possibly pull out. There are 2 x's here, there are 3 here, and there are 4 here. So the greatest number I can pull out is 2, because this has 2, this has 3, and this has 4. So I can take 2 from here, I can take 2 from here, and take 2 from here without, not having enough to pull out. So I'm going to take out a 5. I'm just going to rewrite that. I'm going to take out a 5 and then the x squared. And again, to show that, or to make sure you don't make a mistake, what you can do is divide each piece by 5x squared. And then, divide. So 5 and 5 cancel to 1, and x squared cancel, but be careful, this becomes a -1 because of that negative sign there. And the next term, the 5 and the 5 cancel, the x word cancels with the x cubed, but you're only left with x on the top, so that's minus x. And then you have the 5 and the 5, that becomes a 3. The x squared cancels out this x to the 4th, and that becomes x squared. So I have minus 3x squared. So that's how you factor this one. The next type of factoring you guys learned was dots, and dots stands for difference of two squares, meaning that you need subtraction, which stands for the difference, so this does have subtraction. 2, meaning you need a binomial, and squares, meaning that they are both able to have the square root taken of them. In this first example, it is difference of two squares, it's subtraction, and I can take the square root of both of them. Because I can do that, I'm going to break it up into 2 separate binomials. The square root of x squared is x and x. The square root of 25 is 5 and 5, and then I have plus minus. This is my answer here. And the reason why you're breaking up a binomial into 2 separate binomials is because, well, first off, the signs are different so that the middle term cancels out. And again, if you don't believe me, you can check yourself by doing the box method or FOIL. I'm going to do the box method. So here you see x squared minus 5x plus 5x and 25 minus 25. These cancel, and that's how you get back to your binomial that you started with. Now the next one's the same idea. It's difference, meaning subtraction, of 2. There are 2 things, and they're perfect squares because I can take the square root. Meaning there is a square root of 16, it's 4. There's a square root of a squared, that's a. And there's a square root of b squared, which is b. And you always separate it with plus and minus in the middle. So that is your answer there. Now sometimes they put GCF and dots together, so the first thing you should always think of is GCF. Now looking at this polynomial, I should be able to see that 125 and 20, they should have a common factor. 20's factors are 2 and 10, 5 and 4, and 1 and 20, and there's other ones as well. But you want to be able to pull out the greatest common factor out of 20. So out of 20, I can pull out a 5. That goes into 125 as well. So if I pull out a 5, this 125 divided by 5 is 25 minus 4v squared. It's 4 because 20 divided by 5 is 4. Now, you always need to ask yourself, can I factor any further? This can be factored further. The 5 would just drop down, but if you look at the inside of the parentheses, it is a difference of two pieces that are perfect squares. And they are perfect squares because, 25 and p squared are perfect, and 4 and v squared are perfect. The square root of 25 is 5, and the square root of p squared is p, plus minus as always, and the square root of 4v squared is 2v. This is how you do dots with GCF before it. Alright, I hope this video helped. I'll see you guys soon.